Hello, I am Dharma Teja, working as an assistant professor in civil engineering department from Mlritm college. Today we are going to discuss about a small topic, basic elements of geometric design in a subject transportation engineering. The first basic element we are going to discuss is about design speed. Design speed is a selected speed used to determine the various geometric design features of the roadway. The selected design speed should be a logical one with respect to the anticipated operating speed, topography, adjacent land use, modal mix, and the functional classification of the roadway. Key points. It provides a basis of the geometric design elements such as horizontal curves, vertical curves, and side distance. It should be consistent with the terrain, traffic conditions, and the function of the road. It is not necessarily the same as the posted speed or the operating speed, though they are somewhat related. Design speed basically depends on the two factors. The first one is importance of the road, and the second one is terrain or topography through which it is passing. Okay, first one, if you are taking first one, importance of the road. Okay, based on the importance of the road, whether it is a expressway, national highway, state highway, up to village roads, if we observe the speed, okay, for expressways we are maintaining the higher design speed. Okay, for village roads the speed is lower. Okay, as we observe here, the speed is decreasing, okay, from high speed to low speed based on the importance of the road, that is expressway, highways, state highways, mandal district roads, ordinary district roads, village roads. Okay, the speed will be decreasing from high speed to the low speed. And the next is terrain. Okay, there are different classifications of terrain: plain terrain, rolling terrain, mountainous terrain, and steep terrain. The terrains are classified based on the cross slope. Okay, cross slope is nothing but the camber. Okay, for plain terrain 0 to 10% cross slope, for rolling terrain 10 to 25%, for mountainous hilly terrain 25 to 60%, and for steep terrain it is greater than the 60%. Okay, based on the cross slope the terrain is classified into four types: plain, rolling, mountainous, and steep terrain. Okay, here also if you observe, for steep terrain the speed will be low. Okay, whereas for plain terrain the speed will be higher. Okay, that means high speed, here it is low speed. And what do you mean by ruling design speed and minimum design speed? Ruling design speed is maximum most possible speed on the road is the ruling design speed. Okay, and minimum design speed is the lower limit of the speed. The design speed we can say it as 98 percentile speed in terms of percentiles, and for minimum design speed, if we observe, it is 15 percentile speed. Okay, the next other element we are going to discuss is about friction. Whenever we are talking about the friction, we are talking about the friction between the tires and the pavement. Okay, pavement may be of flexible pavement or rigid pavements. Okay, that means asphalt pavement or the cement concrete pavements. Okay, is critical for the vehicle control. Okay, without the friction the vehicle won't stop, right? So friction is an important critical factor in order to control the vehicle stopping. And there are skid and slip. Okay, vehicle slides uncontrollability due to the lack of friction. If the friction is very less, then what will happen? Friction between the tire and pavement is very less, then what will happen? The vehicle will skid on the road. Okay, slip. Okay, relative motion between wheel and the pavement. Whenever we are suddenly accelerating or suddenly braking, this slip comes into the picture. Okay, next is adequate friction ensures safe stopping and maneuvering. Okay, that we discussed. Stopping side distance. Okay, the friction plays the major role. Longitudinal friction. Okay, 0.35 to 0.4. Okay, longitudinal friction means it is along the road, that is used in the stopping side distance. And the lateral friction, which is 0.15. Okay, used in the design of the horizontal curve. Okay, It is across the road. Lateral friction is across the road. Next is pavement unevenness. Pavement unevenness index is the numerical value that is representing the degree of unevenness or roughness of a pavement surface. Usually it is expressed in the millimeters per the kilometer. Okay, it is generally measured using the bump indicator, roughness indicator, and inertial profilometer. Okay, the device records cumulative vertical displacements of the vehicle axle over a known distance. Okay, that is unevenness index. In the numerator we will be getting the total vertical movement, okay, in mm, and the next is distance traveled, that is in kilometers. Okay, therefore the unit will be in mm per kilometer. What is the importance? The importance of pavement unevenness is it affects the ride comfort and vehicle speed. For a good pavement, okay, for a good ride quality, then the good unevenness index should be of 150 mm per kilometer. Okay, as it affects ride and vehicle speed. Okay, influences fuel consumption. Okay, assume if the unevenness index is more, then the fuel consumption will be increasing, the vehicle maintenance cost will be increasing. It helps to determine maintenance and rehabilitation needs of the pavements. Okay, used in road condition surveys and pavement performance evaluation. And the next is cross slope. So discussed in the terrain classification, camber or cross slope is the slope provided to the road surface in the transverse direction in order to drain off the rainwater from the road surface. Okay, the rate of camber, it is usually expressed in the 1 in n, that means 1 vertical to the n horizontal. Camber mainly depends on the two parameters, that is type of the road surface, okay, and rainfall. Rainfall means we classify them into heavy rainfall, okay, moderate rainfall and less rainfall. And in types of road surface, we will be classifying into cement concrete or high bituminous surface, thin bituminous surface, waterborne macadam or gravel road, earthen road. Okay, if you observe, for cement concrete is a high bituminous road, we require less camber. Okay, as the surface quality is very good, so the less camber will be enough. Okay, for earthen road, there will be more slope, the camber should be more. Okay, similarly, if you take the rainfall region, for heavy rainfall, we need the more camber, whereas less rainfall regions requires the less camber. Okay, as the amount of drain water should be will be minimum here for less rainfall areas, so less camber will be enough there. Okay, this is the cross slope provided, okay, for the types of road surface with the rainfalls. For cement concrete to high bituminous, if you observe, 1 in 50, okay, for heavy rainfall regions, whereas in light rainfall regions it is 1 in 60. As we go from, as the quality of the road surface decreases, that is from cement concrete high bituminous surface to the earthen road, what is happening? The slope is increasing, we are increasing the slope. Okay, if we compare the heavy rainfall and light rainfall regions, heavy rainfall regions is having more slope compared with the less rainfall regions. Okay, and there is classification, there are types of cambers. Okay, one is parabolic camber, straight line camber, combination camber. Parabolic camber, it is used mainly in the flexible pavements, that is asphalt pavements, because psychological problem is there for all drivers tries to move in the flat region, so chances of rutting is more. Okay, what is happening here? In the asphalt pavements, the more the vehicles travel to move at the centers. Okay, move at the centers, so what will happen? There will be a rutting happening here. Okay, so that is the main drawback here. The next is straight line camber, used mainly in the rigid pavements. Okay, so what will happen? In the rigid pavements, there will be a sharp edge at the minimum if we provide a straight line camber. So what will happen? The overtaking operations will be a problem here. So there is a combination camber in order to take over this disadvantages of the parabolic camber and straight line camber. Okay, so combination camber, it is used in both flexible and rigid payments. It covers the drawbacks of the both parabolic and straight line camber. The center portion is kept as parabolic, whereas edges it is kept as a straight. Okay. What is the basic purpose of the camber? In order to remove the rainwater from the pavement surface as quickly as possible, we provide the camber. To prevent entry of water into the bituminous pavement layers. As we know, for any pavement there will be a different layers. So in order to enter the entry of water into the subgrade, so we provide the camber, okay, in order to drain off the water. To prevent entry of surface water into subgrade soil through the pavement. And last is to make pavement surface attractive, okay. And this is the cross section of the highway, okay. Carriageway means shoulders, okay. Carriageway plus two shoulders, we call it as a formation width, and formation width plus two road margins, we call this as a road land, okay. And there are control line, building line, and road boundary line, okay. Pavement width, okay, it depends on the number of lanes and the traffic volume. IRC recommends for single lane, the road width that should be provided is 3.75 meters, whereas for two lane without curbs, it is 7 meters, and two lane with curbs, it is 7.5 meters, and if it is a intermediate carriageway, it is 5.5 meter, okay. How come they have arrived at this? Because if we take the design vehicle, the width of the design vehicle, okay, the width of the design vehicle, we consider it as 2.44 meter, okay, and the offset is 0.66 meter, okay. From this, we will be arriving with the width of the single lane, that is 3.75 meter, okay. Road shoulders, okay. Shoulders are provided along the road edge to serve as an emergency lane for the vehicles. As per the IRC, the minimum width of the shoulder should be of 2.5 meters. What are the uses? Repair of broken down vehicles, okay, and second is overtaking operations. It acts as an emergency lanes, and for the future widening of the road, for temporary diversion of traffic during the road repair, or if any accident occurs, in order to divert the traffic, we use the shoulders, okay. Formation width, as we discussed, total width of the road embankment including the carriageway plus two shoulders on the right and left, that we call it as a formation width. For two lane rural highway, 7 meters if you observe as a pavement width, okay, that is carriageway width, and 2.5 meters of each shoulder width, then the total width, that means the formation width is 12 meters, okay. And right of way, or we call it as a land width, total land acquired for road, that means that formation width plus side drains plus future widening, okay. It depends on the road category. That means example, if national highways, it requires 45 to 60 meters. And the last one that we are going to discuss is about super elevation. Super elevation is the transverse slope provided at horizontal curve to counteract the centrifugal force by raising the outer edge of the pavement with respect to the inner edge throughout the length of the horizontal curve. So what is happening here? Whenever the vehicle is maneuvering the horizontal curve, it is affected with the centrifugal force, okay. So in order to counteract the centrifugal force, what we are doing, we are raising the outer edge of the pavement with respect to the inner edge, okay. So super elevation helps the vehicle to overcome the centrifugal force on the curves, okay. The need of super elevation on road curves is to ensure safety against skidding, overturning with the advent of the fast moving vehicle, okay, fast moving traffic. This is the pictorial representation, okay, of super elevation. We are raising the outer edge. So what is happening here? Centrifugal force is acting, the lateral acceleration, okay, and the friction, lateral friction is counteracting the centrifugal force. These are some of the references. We are going to continue in the further classes. Thank you.